Hello and welcome to Learn Yourself. Today we are going to learn about type of chemical reaction. This topic is under ICSE Standard 8 syllabus from the chapter Chemical Reactions. When we are learning chemical reactions, it is very important to learn how many types of reactions are there. So in Standard 8 syllabus, there are total 8 type of reactions. Let us have a look on them. So direct combination reaction, decomposition reaction, displacement reaction, double decomposition reaction, reversible reaction, catalytic reaction, exothermic reaction and endothermic reaction. When we are learning this, for each and every type of reaction, you should remember the definition of it. You should remember one example each for each of the type of the reaction and you have to explain the reaction. Let us see one by one each and every reaction with their suitable example. Let us learn the first type of chemical reaction, that is direct combination reaction. This is also known as synthesis reaction. So as the name suggests, when one compound or element is reacting with another compound or element and they are getting one compound, it is known as combination. What all reactants we are getting, they all will react together and they will form only and only one compound. There are three types of reaction in direct combination reaction. First one is compound will react with element. Element will react with element and compound will react with compound. So in all these three cases, they will only get one compound at the end. Whatever you are getting, a reactants A plus B, they all will combine and make only one new compound. That's why it is known as combination. What all reactants are there, they all will combine. So that's why it is known as combination reaction. So when compound is reacting with element, so we have taken here carbon monoxide. When it reacts with element oxygen, it will give us carbon dioxide. In the second type, element will react with another element and gives us compound. So carbon is an element, is reacting with element oxygen and gives us carbon dioxide. In third type, compound will react with compound. So calcium oxide is a compound, is reacting with water, that is also a compound. So calcium oxide and water will combine and gives us calcium hydroxide. So all these are example of direct combination or synthesis reaction. Let us see decomposition reaction. Decomposition reaction is exactly opposite to combination reaction. When any one reactant we are taking and we are heating it, it will decompose into compound or element. So this is exactly opposite to combination or synthesis reaction. So there are three types of reactions. When we are taking a compound and we are heating it, we will get either compound plus compound or element plus element or compound plus element. So here in first I have taken calcium carbonate. When we are heating it, we will get calcium oxide plus carbon dioxide. So in this case, we are getting two new compound while we are decomposing this. Means when we are breaking this with the help of heat. When we are keeping this symbol, that means we are heating it. It requires heat. Decomposition reaction always require heat. So the triangle symbol on the arrow suggests that we are heating this compound. Second reaction, in which compound when we are heating, we will get element plus element. When we are taking mercuric oxide, we will get mercury plus oxygen. These both are element. So this also we need to heat. And in the third type of reaction, when we are taking compound and when we are heating it, we will get compound plus element. So in this reaction, when carbon dioxide we are taking and when we are decomposing it, we will get carbon monoxide and oxygen. If you will see carefully, all this type of reaction are exactly reverse to the combination reaction. We have taken in combination reaction compound plus compound and we were getting compound. Element plus element and we were getting compound. Compound plus element and we were getting compound. Here compound we are taking and we are getting either compound or element as a product. So this is a decomposition. When we are taking one compound as a reactant and we are heating it, when we are decomposing it as a product, as a result we will get either two compound or two element or one compound and one element. Decomposition reaction we are carrying out by four different ways. First is thermal decomposition, second is thermal dissociation, third is electrolytic decomposition and the last one is photochemical decomposition. So first one is thermal decomposition. The reaction we are doing, the decomposition we are doing with the help of heat, that is known as thermal decomposition. Thermal name suggests that heat. So thermal decomposition we are carrying out with the help of heat. So the example is a mercuric oxide. When we are heating it, we will get mercury and oxygen. The second one, thermal dissociation. This is thermal decomposition and this is thermal dissociation. These two are different. This is also we are carrying out with the help of heat. But this reaction is reversible, whereas this reaction is non-reversible. Once the mercury and oxygen has been formed, it cannot go back by its own. Here, ammonium chloride, when we are heating it, it will dissociate into two simple compound, ammonia and HCl. Once the reaction mixture will cool down, it again convert into ammonium chloride. So when we are giving heat, it will gives us ammonia and HCl. Once it is cooled down, it again converting into ammonium chloride. So this is the basic difference between thermal decomposition and thermal dissociation. In dissociation, the reaction is reversible, whereas in decomposition, the reaction is non-reversible. But both the reaction we are carrying out with the help of heat. Then third one, electrolytic decomposition. Name itself suggests that we are using electricity in this reaction. Electrolytic, we are using electricity. So when we are using water and in the water we are passing electric current, we will get hydrogen gas and oxygen gas. This reaction is an example of electrolytic decomposition. Then the fourth one is photochemical decomposition. Photochemical name itself suggests that it occurs with the help of sunlight. So the silver salt, this symbol suggests that with the help of sunlight. The star symbol always we are using for sunlight. So when a sunlight directly falls on silver salt, it will decompose into silver and chloride. They are very unstable salt. So in presence of sunlight, they can decompose. So the photochemical decomposition we are carrying out with the help of sunlight. Only this name has dissociation. Rest all are decomposition, decomposition and decomposition. Since this is dissociation, it is reversible reaction. Rest all are non-reversible reaction. Thermal decomposition, we are using heat. Electrolytic decomposition, we are using electric current. And photochemical decomposition, we are using sunlight. Now let us discuss displacement reaction. The name itself suggests that it displaces something in reaction. So one element will displace another element from the compound. So that is known as displacement reaction. In this, we require this activity series of matter. So this is known as activity series, and this series will tell us that which metal is reactive compared to another metal. So if you can see here, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum and gold are there. Also hydrogen is also there, even though the hydrogen is a gas, because hydrogen acts as a metal or proton donor. So scientists have given the place to hydrogen also. Now all the metals which are placed above hydrogen are known as active metal. Their reactivity is more compared to the below metal. Now whatever metal is placed above, they are very reactive. So the first metal is the most reactive metal and the last metal is the least reactive metal. That means potassium is more reactive compared to sodium. Sodium is more reactive compared to calcium, and calcium is more reactive compared to magnesium, and so on. So this is our activity series which tells us which metal is reactive compared to another metal. So let us check the definition of displacement reaction. The chemical reaction in which element placed higher in activity series displaces the element placed below it. That means potassium can displace sodium because potassium is more reactive compared to sodium. Sodium can displace calcium and so on. But calcium cannot displace sodium and sodium cannot displace potassium. Let us check one example. Here I have taken zinc, copper sulfate. When these two will react, it will form zinc sulfate and copper. It says that zinc is displacing copper from copper sulfate. So zinc is placed here and copper is placed here. Zinc is upon the copper. That's why zinc is very reactive, and that's why it could be able to take the place of copper. If this reaction has been reversed, for example it is ZnSO4 plus Cu will be there, then this reaction cannot possible because Cu is not reactive compared to Zn. It is less reactive, so it cannot take the place of zinc. Let us check one more time the definition, that chemical reaction in which element placed higher. Element placed higher. So zinc is higher than copper. Activity series displace the element placed below it. So all this element can displace copper, but copper cannot displace all this element. To remember this type of reactions, you have to remember this sequence of activity series. Then only you will get to know that which metal will displace another metal. Double decomposition reaction. The name itself suggests that the decomposition will be doubleized. There will be two different decomposition in one single reaction. We have seen decomposition in which one reactant will decompose into compound or element. Here two reactants simultaneously will decompose. So that's why it is known as double decomposition reaction. Now let us first see the definition. Reactants are decomposes and give two new compound by exchanging their radicals. How they are exchanging their radicals? For example, this is one compound, this is another compound. So here X is a positive radical, Y is a negative radical. A is a positive radical, B is a negative radical. So they are exchanging their radicals. So positive radical of first will take and will go with the negative radical of the second reactant. It cannot go with positive. Positive radical cannot combine with another positive radical. So they are exchanging their radical. And this negative radical will go with the positive radical of second reactant. In one compound there will be only two radical, one will be positive, one will be negative. So they are exchanging like this, and as a result we are getting X plus B minus. This is one compound, and the second one is A plus Y minus. This is second compound. So the reactants both has been decomposed. Both have been decomposed. How? Earlier it was XY, now it is XB. When we are breaking the reactant, it is known as decomposition. So they both are decomposes. So they both are decomposed. How they are decomposed? That by exchanging their radical with each other. So in double decomposition reaction, there will be two reactant and they both will exchange their radical and we will get two another new compounds. There are two types of double decomposition reaction. First is neutralization reaction. Second one is precipitation reaction. What is neutralization reaction? When acid will react with base, it will give us salt plus water. What is acid here? HCl. Hydrochloric acid will react with base, that is NaOH, and will give us salt and water. This is neutralization reaction. Second one is precipitation reaction. What is precipitation reaction? When any compound in aqueous form, when we are writing in the bracket AQ, that means the medium is aqueous. When we are dissolving that salt in the water medium, that is known as aqueous solution. So one compound in aqueous solution, another compound is also in aqueous solution. That means two solution we are mixing it with each other and we are getting one compound in aqueous medium and another compound we are getting as a precipitate. That means when you are mixing two aqueous medium compound with each other, you will get some solid compound. And when you are filtering it, one solid compound will come as a residue, and whatever left the solution in that, the another compound will be there. So let us take one example, that is sodium hydroxide will react with silver nitrate and it will give us sodium nitrate plus silver chloride. So when two solution we are mixing it together, we will get NaNO3, sodium nitrate in liquid and AgCl as a precipitate. So you can filter it out and as a residue you will get AgCl, and in the liquid your another compound will be there, that is sodium nitrate. So there are two subpart of double decomposition reaction. That first one is neutralization reaction and the second one is precipitation reaction. Catalytic reaction. So what is catalyst? Catalyst is a compound which enhances the rate of reaction or suppress the rate of reaction without taking part in the reaction. So basically the catalyst is, it changes the rate of reaction. It will change the speed. So if catalyst is a positive catalyst, then it will increase the speed. If the catalyst is a negative catalyst, it will decrease the speed of reaction. Now there are total three types of catalytic reaction. And in that, one is positive catalyst, second one is negative catalyst, and the third one is promoter. Positive catalyst will increase the rate of reaction. When we are taking hydrogen peroxide, we are decomposing it, we are using manganese dioxide. So manganese dioxide is catalyst and it will increase the speed of reaction and we will get water and oxygen. Negative catalyst. So negative catalyst, we are using alcohol. It will suppress the rate of reaction. It will decrease the speed of reaction. The third one is promoter. Promoter is a compound we are using along with the catalyst. So it will help catalyst to enhance the rate of reaction. When we are taking this example, nitrogen will react with hydrogen. We are using iron plus molybdenum Fe or MO at the temperature 450 to 500 degree Celsius. We will get 2 molecules of ammonia. Here this Fe is catalyst and molybdenum is promoter. So molybdenum will help iron to increase the rate of reaction. So molybdenum is not a catalyst, it is a promoter which will help catalyst to increase speed of reaction. So catalytic reaction is a reaction which takes place with the help of catalyst. And there are 3 types of reaction: positive catalytic reaction, negative catalytic reaction, and the reaction which will occur with the help of promoter. In our body, enzymes are also one type of catalyst which will enhance the rate of our metabolic process.